Good afternoon, ladies and gentlemen. We are looking forward to an exciting conversation with the chairman of the board of management of Daimler AG, Mr. Ola Källenius, and the Nobel Prize laureate for chemistry of the year 2019, Dr. Akira Yoshino. Mr. Källenius, you are now in the studio in Stuttgart. We would have loved to welcome you on stage in Duisburg. With this corona is unfortunately not possible. How does it feel to meet the inventor of the lithium-ion battery? Without this innovation, there would be no electric cars, would there?
Yeah, Mr. Dudenhöffer, thank you for inviting me to this talk. I was very excited, and I'm honored to meet Akira Yoshino. I think he's a living legend. The research that he has done and working on this technology already back in the 1980s, if that type of research wouldn't have happened, we wouldn't have the opportunity to roll out the big fleet of electric cars that we have in the pipeline at this stage. And as a matter of fact, Mercedes was one of the very first manufacturers that bet on lithium-ion technology. We did a hybrid already more than 10 years ago with lithium ion, when a lot of people said, well, let's see, is the technology already there? So I think we have to be thankful that people, researchers like Mr. Yoshino just breaks new ground and pushes the boundaries of technology.
Good day to Tokyo, or rather good afternoon, Dr. Yoshino. We had the pleasure of welcoming you at our Car Symposium in Bochum, just a few months before the announcement was made that you was awarded with the Nobel Prize. It is a great honor for us to talk to you today via video. Unfortunately, Corona has ruined your travel plans.
Thank you very much. And I wanted to visit Duisburg this month, but I can't because of corona issues. And last year, I attended your car symposium in Bochum. After that, I was informed of the Nobel Prize. I remember it very, very impressively. Thank you.
Ladies and gentlemen, let's begin today's discussion with the Nobel Prize laureate, to Dr. Akira Yoshino and Ola Källenius, with the sentences of the Royal Swedish Academy of Science at the presentation of the Nobel Prize for Chemistry in 2019. The works of Goodenough, Whittingham and Yoshino changed our world, writes the Nobel Committee. Not only has the lithium-ion battery enabled the evolution of electronics from stationary to portable devices, but also the still ongoing transformation of mobility from fossil fuels to electronically powered vehicles. Dr. Yoshino, the Nobel Prize is the most prestigious award a scientist can receive. If you look at the Nobel Prize winners this way, they usually come from universities or governmental research institutes. You have been with, as I can say, for your entire career. What distinguishes research in companies? Research in industry is product-driven. What does that look at, as I can say? Why does your company allow itself the luxury of letting Nobel Prize winners do research? To what extent are they involved in specifications and budgets? Or can they do everything that will provide them with new insights?
Okay, thank you very much. Very important questions. So I want to answer in Japanese and then we translate in English.
That's an excellent question, thank you. I think it's very meaningful that I, as a researcher in industry, won the Nobel Prize. This is an important point, so I'd like to elaborate. Of course, commercialization is the final aim of research in a company, but there are various stages of research in a company. For example, if there are 100 people working in a laboratory, 90 of them are doing research projects for commercialization, and the other 10 can perform basic exploratory research. The 10 doing basic research are trying to make something from nothing in a completely unknown field. In general, they work alone, so this is a very lonely and difficult job. Also, the chances of success are very low. But if nobody does this, nothing new will be created. So it's not surprising if one small part of this research results in something worthy of a Nobel Prize. And I don't think this is peculiar to Asahi Kasei. I think it's the same in any company. Basic research is only about 10% of all the research, so it doesn't take a huge amount of money.
Mr. Källenius, you must pay attention to EBIT and deliver results to your stakeholders. Can you imagine hiring a young Yoshino at Daimler and having him do research for a Nobel Prize?
Absolutely. You need the best and smartest people around the world, also on the research side. And we have a very long tradition in research where we take the long view, not just the product development where we're focusing on something that is going to be in the market maybe in the next 3 to 5 years, but also look 10 years and beyond. And as a company, what you have to accept when you do research is, even if you're a business for profit, obviously, you try to make things that come into the market, you have to accept that not every egg becomes a chicken, and you have to have an open mind. So we also have a great team of bright minds doing research. So we would definitely hire a young or an old Yoshino to work with us on changing the world of mobility. Once you get into the next stage and you take some of the best research ideas, that's when you become more concrete and go into product development. But to have basic research inside your company is crucial, and also work with other organizations such as universities or other companies to push technology forward.
So it's interesting. You could hire Dr. Yoshino. Great to hear. Dr. Yoshino, could you tell us a little bit more about how it looks like with you and Asahi Kasei? How do you coordinate your research and your research budgets with the management? What freedom do you have, and what are the limits, for example, in comparison to research at universities and governmental institutions? How important is the topic of commercialization?
Once again, I don't think Asahi Kasei is unique in this regard, so I'll give you a general answer. The head of R&D negotiates with the management to get the R&D budget. For example, let's say this is a few percent of the company's total revenue. The head of R&D allocates his budget to various research projects. Probably 90% is allocated to commercialization projects, and the remaining 10% is for basic exploratory research. This is on the condition of producing results in 10 or 20 years, but other than that, there is great freedom. In a sense, there may be a greater degree of freedom than with the research at universities or national laboratories. But, of course, not all the researchers will be doing this kind of research.
Thank you. It's interesting, Mr. Källenius, to hear they take 10% of its research budget to make research which is long-term research and is not product oriented. Could it be interesting to take this Yoshino model, or to make this Yoshino model also available for companies in Europe, in our companies, in our world, how far can companies allow themselves to carry out a basic research that might even produce Nobel Prize winners? You at Daimler, you have a basic research department. What do you think can we learn in Germany, in our companies, from the SAKZ model for basic research to advance more our economy, our competitiveness in the future?
We have a very similar line of thought. The model that they apply is something that resonates with me, whereas we don't disclose exact percentages and how much we spend on each area. You have to have that approach. One part of the budget really needs to be free and look far into the future and not just be dedicated to the next product program. But beyond what you do within your own four walls here in the company, you need to reach out as well, in my point of view. We have a network of both universities but also research institutes that we work together with on different topics. And in some cases also either with other big companies where we share the view on a certain technology and we want to see if we can take it to the next level. And then make occasional bets also on startups. Quite often it's a bright couple of people or three that have an idea and actually start from scratch that can match the ingenuity and the creativity of larger organizations as well. So we reach out in all directions. And I think it's necessary because if you don't have this mindset of curiosity, then you're not going to make technological progress. So even in a very hard commercial competitive environment, there needs to be room for this.
So we are close together to the Yoshino model and to the European model to make advances in research and development to get to new technologies. Looking at new technologies, let's look a little bit at the lithium-ion battery. Dr. Yoshino, what are the next steps in lithium-ion batteries? What's about the solid-state battery? When will we industrialize solid-state batteries, and what are the advantages? It's just higher energy density, or do we also have to go to better cost developments with solid-state? What's new or what can you tell us in that topics?
For a new technology to become a product, I think two kinds of breakthrough are needed. The first breakthrough is in basic research, and the second breakthrough is in mass production technology. I think we need to consider next generation battery technologies from this perspective. Regarding the solid-state battery, in 2011, Professor Kanno of Japan discovered a solid electrolyte having astonishingly high ion conductivity. This clearly was the breakthrough on the basic research level. Currently, the focus is on making a breakthrough in mass production technology for the solid-state battery. It is expected that the solid-state battery will have stability at high temperature, including improved safety, and for electric cars this means the battery cooling system could be unnecessary. There are other next-generation battery technologies being researched, but unfortunately they haven't had a breakthrough in basic research. We're still waiting to see if this breakthrough will be achieved.
So, Mr. Källenius, listening to Dr. Yoshino, the battery development is proceeding pretty fast. Do you still need cars with combustion engines then? Your plan is to phase out combustion engines by 2040, if I understand it correctly. Yesterday, the EU Commission announced plans to go up with stronger CO2 regulations, which means that we will speed up the process into battery electric vehicles. So what's about your plan? Do you still have your plan in 2040, or do you see it's possible to speed up the process to go over to electric vehicles?
We see the development of batteries right now is very dynamic. Also on the fuel cell side, we presented yesterday a long-haul truck that can do over 1,000 kilometers using a fuel cell that we want to put into commercial production in the second half of this decade. And we're watching many of these developments where you have, as Mr. Yoshino said, very promising and proof of concept on the research side, how they are potentially developing into volume production sometime in the future as well. Solid-state battery is one of those. So I think the dynamic technology development will in part answer this question. Once you get to an energy density that you can take away some of the other limitations that we have today in terms of range and perhaps the time it takes to charge the vehicle, it will accelerate this development. But we have to keep something also in mind. We're in a major transformation, not just of the automotive sector, but of society as a whole towards a CO2 neutral future. And three things need to go hand in hand. Of course, the product itself, in our case, the car, and I'm optimistic about our ability to create exciting products that will be emission free. But you also need the energy source needs to come from a CO2 free source. So it only makes sense if it is renewable energy that ultimately powers this vehicle. And that will lead to a third task that we have as a society, is to build up the infrastructure. If those three things go hand in hand and we can accelerate those, then this paradigm shift into ultimately emission-free mobility will go quicker. As Daimler, as Mercedes-Benz, we have said we want to be one of the architects of this transformation. We're embracing this challenge. We have some of the best engineers in the world working for us. Let's try to solve this problem. And with the ambition 2039, we have given ourselves our own, I would say, target to say in about 3 product life cycles. Let's see if we can engineer ourselves into a position where we, for Mercedes-Benz cars, can go emission-free and take an optimistic view on this.
So, Dr. Yoshino, Mr. Källenius just mentioned they present in a truck with a fuel cell. Germany at itself wants to become world champion in hydrogen. How do you assess the importance of the fuel cell and the hydrogen economy? Will it be a competition between fuel cell and battery? And if yes, which of the two technologies will dominate?
I think which system becomes optimal will depend on how the future of mobility evolves. I believe CASE represents the future of mobility, C-A-S-E. I think it was Daimler that proposed this concept about 3 years ago. When we transition to the world of CASE, the optimal system will be determined. The E from CASE means electric, and I think vehicles will be electrified. The future of hydrogen depends on whether there is a low-cost supply of clean hydrogen. If that becomes possible, electricity generated from hydrogen and steel made using hydrogen will have a huge impact on industry.
Mr. Källenius, you just mentioned that you presented that fuel cell truck yesterday, and Daimler by itself has a lot of experience in this field. On the other hand, Elon Musk says he uses lithium-ion batteries for trucks, for example, for his Chemie. Is Elon Musk on the right track? Is he right?
I don't want to pass judgment on other companies' strategies, but what we are doing now is, if I look at our portfolio from cars all the way up to heavy-duty trucks, long-haul trucks, we have made a clear decision here in the years to come that for cars, we're now betting on battery electric vehicles because it's the fastest, most economical solution, and energy density is improving literally by the day. With regard to the trucks, we have divided it up into 2 segments. If you take a truck that is driving inside the city and it's transporting goods to many locations, a typical distribution case, we also have electric trucks in the market already. We were one of the first with the e-Canter from Fuso to introduce this concept. And the lithium-ion technology and the size of the battery is very reasonable for that use case. And we also mentioned yesterday that we're going to take that battery electric truck to the next level and have a truck that goes all the way up to 500 kilometers. But if you have a case where you maybe want to go 1,000 kilometers or more in a day, you have this very long haul, we looked at, in the current energy density paradigm, that battery would be so big that it maybe takes away some of the load that you can put onto the truck. And you could argue, does it make sense to make, from an environmental point of view, that big of a battery at this stage? That could, of course, change if there is a significant breakthrough in battery technology, solid state or another, that could change that equation. But from today's point of view, the fuel cells technology for that use case, it offers us a very good solution that is much lighter and relatively easy for us to package. And that's why we have 2 horses in the race. But I agree, ultimately, you have to have an open mind. And what Mr. Yoshino said, that economics will probably decide in the end as well. The one technology that is able to solve the problem of the use case of the customer in the most economical way usually wins. So here we are making sure that we have both these horses in the race.
I see Elon Musk has to do some homework. We'll see what happened. So let's go to the closing remarks of this meeting today. Dr. Yoshino, we are linked via video today due to Corona. Corona has changed the world dramatically. What does Corona mean for research? Social distancing will make personal exchange more difficult. Will it set back research? Perhaps you will visit your laboratories less often. What does the scientific world look like after Corona?
Social distancing and remote working are most difficult at manufacturing plants and research laboratories. In research, it's important to do hands-on experiments and discuss results with other researchers. So in that sense, there's a big negative. But there may also be a positive effect, and I say this based on my own experience. When your research hits a wall, you become desperate to get an answer, and you start doing experiments haphazardly. Maybe the Corona forces you to slow down and take more time to examine the problem more carefully. And in the end, this might enable to get better results more quickly.
Thank you, Dr. Yoshino. So it is difficult for researchers to go through the difficult world in times of Corona, and we are looking forward after Corona. However, as I understand, Corona has a positive and a negative side, and sometimes the positive side could also help us to speed up our research. Dr. Yoshino, I could imagine you possibly have 1 or 2 questions to Mr. Källenius. Is that the case?
I have one question.
Mr. Källenius, I'm curious about Daimler's concept of sustainable luxury. What does it mean, and what will you require for materials and systems that you procure for this?
Next to what we have been discussing here, the very big task to ultimately solve the CO2 problem, there is another perspective, another aspect of a sustainable business strategy, or also of a sustainable product that we have to tackle, and it's resource preservation. If you look at the materials that go into a car, of course you have different types of metals, high-strength steel, aluminium and other metals. You have polymers of all kinds, but you also have natural materials such as wood or leather. What we are working on is keeping our customers' wishes in mind is how can we increase the use of secondary material so that we ultimately get to what people refer to as a circular economy, as opposed to just taking primary materials and adding to our production volume. Our goal is to try to decouple the growth of our company, the growth of our sales, from the use of materials. So we are setting targets for our vehicle projects and into the future to increase the percentage of these secondary materials. Very important will of course be the battery side, because so much material goes into that. But also work on replacing materials. We already today have artificial leathers that are so good that you can hardly notice anymore whether it's real leather or artificial leather, and many customers prefer that. So we have to keep both of these tasks in mind as we go towards a more sustainable economy and also society. That solving the CO2 problem may be the biggest challenge for mankind in the next decades, but also work on resource preservation. That's our strategy.
Thank you, Mr. Källenius. I could imagine there's possibly one question left from your side, which you want to pose to Dr. Yoshino.
Well, I would like to pose an invitation. It's people like you that make breakthrough research that inspire other people to take the next level. So if you have time, perhaps also past Corona, you're traveling in Europe, if you want to stop by and visit us here and maybe speak to some of our young researchers and tell them about your experiences and how you, as you said, didn't take no for an answer and broke down that wall, that would be an invitation, and maybe we will have some future Nobel Prize winners then also here in Germany.
Thank you. Dr. Yoshino, you see, we are looking forward at the end of the Corona pandemic. We would like very much to have you here in Europe again at the Daimler Labs, but also in other conventions in Europe. So you're welcome in the future to come to us. Ladies and gentlemen, one rarely had the chance to talk to top managers in industry and top scientists about central innovation issues. We are supposed to provide a framework for accelerating innovation and basic research. What can we learn from companies like SAKSI? How do we store electric energy for a wide range of applications tomorrow? How do we manage to provide CO2-free electric energy in sufficient quantities? So it was great, and we appreciate very much to have you today with us, Dr. Yoshino, you, Mr. Källenius. Thank you very much for the time you spent to us. Thank you very much for our conversation.